So overall, it's the same issue, but I have a different angle of looking at it. We will see that. We don't have much time, so I want to answer your questions before you even think about them. Everything that I will be showing runs on 18.2, but there are some new features in DTest, a user command that you may know or may not know, which will be released with version 19. But it can also be downloaded from the public repositories. You just need to know that the name is that DTest is in the dbuild test repository. And I will hopefully be able to take further questions at the end. So what am I going to talk about? Why do we test? What do we test? How do we test? And we have a dog show. But I have prepared this presentation several weeks ago before I even looked at the agenda, and I wasn't aware that I would be talking after Lars and after all this experience. So I'm now preaching to the choir. And I decided some of the basics and fundamentals that I wanted to mention are not needed. So I will skip a few items in the presentation and accelerate. So that should give us more time to focus on the interesting details. Just some of the motivation why we need to test, but I don't want to spend too much time on that. I also don't want to discuss much of the things here. I will be looking at unit testing, but in a broader sense than it is usually used. We are just testing functions here. And I have also used the methods that I'm going to show to test web applications with Selenium and others. So there's great flexibility. So what do? Unit testing means you have a function and you want to test it. I've built a stupid example. Don't try too intensely to understand the APL code. But we should see there are some hidden surprises in this function. So it's probably worth testing it. And I don't want to go into the details, but the things that are important about testing are, first, it should be reproducible. We have seen that. We have heard about automation already. Obviously, a good test should execute code against very diverse inputs. Why does this go automatically? What I find very important is to ensure that every executable part of your code is actually executed. So code coverage plays, for me, an important part, just to ensure that you are really testing all of your code. If you think back, if we look at this function, we see there are some obvious faults in there. So it's important that a test covers that stuff. Okay, enough PowerPoint. Let's demo. Okay, so I met a young statistician, and he was very impressed with the work that he saw from Stephen Mansour, and he was inspired to develop his own statistics package. He thought he could do it better. He handed me some of his source code, and I thought it might be interesting to use that for our demo. This is all he got so far. But I want to point out what I really find inspiring is the ratio of comments and code. If we can keep that until the end, it will be a successful application. Okay, and by the way, you see that he's expressing his gratitude to Adam. I assume that's because some of this code was taken from Apple Card. So what do we have here? Yeah. So we have a user command called DTest. Show of hands, who of you knows DTest or has already used it? Great. Thanks. So the way DTest is 5 years old. Martin started it. And the way we write tests in DTest is that basically we have an expectation of what a function should return. You see that as the left argument to the check function. And then we compare that against the result that some calculation delivers. If the check fails, the if condition will be true. And in that case, the function ends because this condition has not been true. And check and because are parts of the DTest testing framework. They are available to all your test functions. And check, as I said, executes the test, checks the right and left argument, because will append some text message to the log, which is the variable r. So the convention is, if the variable r is not empty, the test has failed. If r is empty at the end, the test has succeeded. DTest, our Dyalog test, our testing framework, will now execute this. Oh, well, Lars has mentioned that we should also make sure that we handle failures of tests. So, one of the things in our test is this last one, and obviously 1 can never be equal to 2, so it will always bail out here. But if we see that at the end of the test, it's fine as well. So if we have done this once, we can comment it out. And run the test again. Just to quickly show one of the many features of DTest that I cannot discuss in detail because of a lack of time. There is the halt switch. And what this will do is if a test fails, because we are not using the match symbol but the check function instead, you will end up in your code at the place where the check failed. You can then inspect the environment, the left argument, the right argument, see how that result was computed, possibly change the calculation and rerun it. Okay, that's enough for now. So as I said, DTest has been around for 5 years. And in May, I sat together with some of our young people, younger than I am, and showed them DTest and was waiting for their feedback, expecting to hear how they like this style. But the feedback was not that enthusiastic. If we look at the test function again, I mean, it's a bit verbose. Obviously, if this check here fails, it's clear that we have a problem with the median function, and it shouldn't be necessary to write a comment about that. We could probably simplify that because we're not interested in the textual comment. It's, in the case of this simple test, it's enough to know that this has failed, because this is a relatively safe result and there's not much to say about it. On the other hand, the verboseness that because offers you might be usable or useful if you write larger applications or more complicated tests. But anyway, as I discussed with them, I scribbled down a way how tests should be formulated according to their expectations. So these days, people would like to use an assert function that checks the expected result against a computation. And if it fails, if the assert fails, well, it fails. There's not much more we need to do. And this technique, by the way, uses empty guards. I don't know if anyone can see the colon here. So that's a dfn with a guard and no code behind it. John Scholes invented dfns. Roger Hui came up with the idea of using these empty guards with assert. And that's a great way to write a very compact test statement. So this is basically the same test as we saw before, just in a style that is more palatable for young people like me. And at the end, if everything is fine, we just return a 0. So that's a problem if we run that test with DTest now, because the code returned a scalar, whereas we were expecting an empty character vector to indicate success. Fortunately, there's a way to achieve this. So if we pass this modifier SuccessValue equals 0 on an entire command line, the test will pass. Great. What else have we got? Yeah. Now in this case, I was running a Dyalog test. I did not execute the test function itself, but rather a test suite. Let's look at the test suite. That's basically a text file, of course. It says which version of Dyalog it works with. It has an ID. And then several parameters which define the test. For example, the success value. So everything in this test will return a 0 to indicate success. Also, tests may have setup associated with it. For example, the coolstat application is stored in a namespace. If we want to test it, we should bring it into the workspace first before running the test function. So some setup is needed, which is what this function will be doing. And then we enlist the various tests that should be executed. we saw, you may have seen the code coverage statement in the test file, and I would like to take a few minutes to make an excursion into code coverage. I have written a simple, stupid function to illustrate, well, just a function to execute. Now, this is the way that code coverage can be tested. There's a package from Kai, code coverage, and with Tatin, we can load it, bring it in. This was live, by the way. So we want to execute a code coverage for the GU namespace. Just make sure there is no code coverage file. Then we start the recording of performance data. We execute the function a few times. It returns a result. We're done. Then we call a function to gather the data and create a report. What? Okay, this should have worked. Normally it does. I wanted to look into the resulting coverage file with you now. I will not try to find out why it didn't work live, because fortunately, the whole coverage analysis can also be done by DTest if you pass the coverage modifier. I'm using a different test subject now just to get more meaningful results. At the end, we see the tests were passed. There were 3 alternative setups that the tests were executed against. The overall coverage is 33%. That's partly because I executed the basic tests, which do not execute the functionality of the whole package. That would have taken too long. And at the end, there's also a HTML file which allows us to find out more about these 33%. So if we look into that, we see when the tests were executed and on which environment, how much memory they used, the 33% that we already saw. Then the functions are distinguished into 4 groups. There are those that were partly covered, uncovered, or fully covered, and all. So the partly covered functions are, well, and uncovered are obviously the most interesting ones. If we can filter this list, as you see. This is the wait function. 6 lines in it were not executed, but the coverage is 83%, it says. No, line number 6 was not executed, sorry. And here's the listing of the function. I'll try to move it up a bit. Bad. So you see line number 6 has a branch symbol at the beginning and is shown in boldface, so that's an indication that it was not executed. So we now know that there is one case which wasn't executed. We may want to modify our code to specifically execute this line. Yeah, been there, done that. Okay, now back to PowerPoint. And I want to talk about multidimensional testing. That's something that nobody has mentioned today, so something new. What we have seen so far was testing your code on the current interpreter, on the current platform you are running on, using DTest, the old dog, and I call this the solo dimension. Now there's a project at Dyalog that we are undertaking. That's the new dog, that's CETA. CETA stands for Continuous Integration and Testing in APL. So the idea is the same. CETA brings with it enhancements where the old dog learns new tricks. So previously, you could only test your code using the Dyalog test files or APL functions. Now, with CETA, you can also provide tests in namespaces, classes, or workspaces in any form you like, using any testing framework you have. They just should communicate the results of their tests in a specified format that will probably be documented one day when I get the time. And this is done using the function execute local test, which enables you to test your code against many interpreters or versions on your local machine. But you can also expand this and run tests on a variety of platforms. The goal of the project was to cover all of the platforms mentioned here, which are the ones that Dyalog is supposed to support. And this is achieved using a tool called Jenkins. Does that sound familiar to any one of you? Yeah, okay. And Jenkins calls through a sequence of scripts the execute local test function, which in turn executes the test. Now, I would have loved to show this live, but I can't because it takes too long. You see, this is when a test is started. You see here, this can take a bit of time. In that case, the test was running 2 hours. Not feasible for a meeting like this. And also, you don't get much spectacular output. This is all you see while the test is running. Not much more. If the test is running and you look at the repository, we see the famous spot that Lars has already pointed out. And it shows you that some tests are currently executed. There's one pending check. When the test has completed, it compiles its result into an HTML table that shows you on which platforms the tests were executed, which interpreters they were tested against, 4 versions of 18, 4 versions of 19, and the test suite that was defined for this repository contained 2 tests, number 1 and number 2. Only 1. Then we see the green background and the checkbox which is the symbol for a successful test. We see the coverage of 34%, and this is linked to an HTML file like the one we saw before, where you can explore those results. The runtime to execute all these tests was an hour, and we have collected 415 megabytes of data from running these tests. If the test was successful, you will be rewarded with my photo and also with a green check mark. So it's immediately reflected on your GitHub repository. And also, if you want to machine process these results, there's a JSON file which has more details that can be used for further processing. So when should we run tests? Well, the name CETA tells it, always. Well, almost, at least on every commit. So the idea is whenever you commit your code to GitHub, this will trigger those tests through the webhooks that GitHub provides. But you may want to test locally before committing. This is what execute local test does, and what I can't demonstrate now because we are short of time. I want to point out this was not a solo effort, but it involved almost the whole company. So many people have contributed knowledge and code to this, and I want to thank them. And we're out of time. Okay, great. Okay, thanks.